Okay. Number 9, prove that the ring Z cross Z is not an integral domain. Now remember, the key property of an integral domain is that it does not have zero divisors, right? To be an integral domain means that you can't take two things that are not zero, multiply them together to make zero, which means if you're not an integral domain, you can do that, right? So to prove that the ring Z cross Z is not an integral domain means we just have to find two elements which are zero divisors, right? Two elements which are not zero, but when you multiply them together, they are zero, right? So in Z cross Z, right, what I mean by zero in Z cross Z would be this element, right? The element 0, 0, right? With 0 from Z and 0 from Z, that's the zero element. And what do I mean by that? Well, I mean that it's the element which when you multiply it by anything, it stays 0. Or equivalently, it's the additive identity in the sense that if I add it to anything, you get that thing, right? So that's what makes it, 0, right? So can you come up with two things which are not that, but when you multiply them together, they make that? And yeah, you can do it something like this. Right? Or I don't know, let's pick, how about that? Right? That yeah, that's from Z cross Z, right? This is from Z cross Z, right? 5's from Z and 0's from Z. And this is from Z cross Z. Neither of those are the actual zero element, which was 0, 0. But when you multiply them together, that's exactly what they become, right? So you've got two things out here which are not themselves the zero elements, like as in the additive identity of the ring. But when you multiply them together, they do become the zero element or the additive identity of the ring. So these are zero divisors. Zero divisors, which means Z cross Z is not an integral domain. So yeah, that's the idea, is that when you are multiplying these two rings together, or direct producting these two rings together, even if they were already integral domains, right? Like Z is an integral domain, it doesn't have zero divisors, and yet when you take the direct product, you gain zero divisors because of this, like, component situation. Like you can have a zero in one component but not the other, and so that allows you to get zero divisors like this. So how about the next one? Let R and S be two rings with unity. Prove that R times S is not an integral domain. So again, you run into exactly the same problem. So let's say let R I'll just say let R be an R and S be an S, where R and S are not zero. So you could pick one, for example, but I'm just going to say R and S, so they could be anything. Well, then you have the same problem. And so maybe I should be a little more thorough. So you run into exactly the same problem. So that means this and this, whoops, those are both elements of R cross S. And yet, and they're non-zero elements for that matter, right? The zero element would be 0, 0, not anything else. So, and yet, when you multiply them together, you do get zero, 0. So these are zero divisors. So really you can see that the proof for the general R and S was really the same idea as for Z and Z. You just take anything with 0 and then 0 with anything, and you multiply those together and you get 0, 0. So it is never the case that the direct product of two rings is an integral domain. If you got a direct product, then you can run into this problem with the components being 0, and so you have zero divisors. So it is never the case that the direct product of two rings is an integral domain. So yeah, so I guess I should finish this up. So R0 and 0s are zero divisors. Technical difficulties. Zero divisors. So R cross S is not an integral domain, period. All right, that is number 8. Sorry, number 9, wasn't that? I'm lost. That was number 9. All right, last one here, number 10. Here we go.